Hello everyone. In this video, we're going to be learning about scientific notation, how to write numbers in scientific notation or standard form, and how to do math with scientific notation. So to start out, let's explain what it is. Basically, scientific notation is a tool. It's another way to write really, really big or really, really small numbers in a less annoying fashion. So the best example I could give you is the mole. The mole is a number that will become very important to us in chemistry, and you'll see why when we get there. But this number is extremely large, so let me write it out longhand. That is the mole. It is unfathomably large, but another way to write that is far less annoying is this. Much faster, and it gives you an idea of how big it is. So again, I just want to stress to you, scientific notation is a tool because you don't want to be writing out numbers of that size longhand. We use numbers in this class like Planck's constant, which is 6.626 times 10 to the negative 34th. We use the speed of light, 3.00 times 10 to the 8th. We use a ton of numbers that are just so annoying to write out longhand that it is far easier to write them in this format. So let's explore how to do that. If I am going from scientific notation to standard form, the rules are that a positive exponent is going to indicate a large number. So to move from scientific notation into standard form, we're going to move our decimal place to the right. So let's say I have the number 1.34 times 10 to the 4th power. That gives me some pieces of information. All right? So this exponent tells me how many places I should move my decimal. And since it is a positive number, I should move my decimal point to the right. So if I'm going to rewrite this number in standard form, I'm going to take this decimal point right here and I'm going to move it 1, 2, 3, 4 spaces to the right. And any empty spaces that you see, you're going to fill them with zeros. So this number in standard form would be this, right? 13,400. Because again, all I took was the decimal point here and I moved it over there, 4 spaces to the right. If you plugged in 1.34 times 10 to the 4th power in your calculator, you would get this answer. All right? The next rule says that a negative exponent indicates a really small number. So you would move the decimal point to the left to change it into standard form. So let's take the number, let's say 5.12 times 10 to the negative 2nd. All right? Again, that exponent is telling you information. It's telling you that you need to move your decimal point 2 spaces. And since it's negative, we're going to move it to the left. 1, 2 spaces. Again, we're going to fill any empty spots with a 0. And our new number is going to be 0.0512. Right? So that's pretty easy. If it's a positive exponent, move it to the right. If it's a negative exponent, move it to the left. So at this point, you could choose to pause the video and you could work through that first set of practice problems by yourself, or you can watch me do it. Doesn't matter to me. In our first practice problem, we have an exponent, positive 5. That tells me that I'm going to move that decimal place 5 places to the right. So I have 3.56. I'm going to move that decimal place 1, 2, 3, 4, 5 spaces over to the right. I'm going to fill in those missing spaces with zeros, and my new answer is 356,000. In number 2, I have an exponent of -4, so I am going to be moving that decimal place to the left. So I have my 1.4. I'm going to move my decimal place 1, 2, 3, 4 spaces to the left. I'm going to fill in any empty spaces with zeros, and my new number is 0.00014. Did you have to put 0 point? No, you could have just written 0.00014. That's fine too. Number 3, exponent of +2. So I'm going to end up moving my decimal point 2 spaces to the right, and I don't even have to rewrite it for that. I can just do that right on here. And so my new number is going to be 568.5. In number 4, I have an exponent of 7. I'm going to move that decimal place 7 spaces to the right. So I have my number 7.8, and I'm going to move it 1, 2, 3, 4, 5, 6, 7. Fill in any of those empty spaces with zeros, and I get this number. Just like that. Last one, I have exponent of -5, so I'm going to move that decimal place 5 spaces to the left. I have my number 3.467. I'm going to scooch that decimal over 1, 2, 3, 4, 5. Fill in any empty spaces with zeros, and I get 0.00003467. All right, so that is going from scientific notation to standard form, but what if we have to go backwards? Well, then we're going to do the exact opposite thing, all right? So let's say I have the number 67,000, let's say. And I want to write that number in scientific notation. Well, first step is to figure out where my little invisible decimal place is, and that decimal place is going to live right here. I don't have to write a decimal place when I'm writing a whole number, but you may want to anyway, just to make it easier for yourself to move that decimal place over to write it in scientific notation. Now, if I'm writing a number in scientific notation, I want to end up with a number between 1 and 9.9. So you are never going to see like 0.34 times 10 to the 6th. That is improper scientific notation. Instead, we would write that number 3.4 times 10 to the 5th, right? Because this number right here falls between 1 and 9.9. So that's where we want to aim for when we're moving a decimal place. In this case, to land on a number between 1 and 9.9, I'm going to move it over 1, 2, 3, 4 spaces and put it right there. So my new number is 6.7. Again, that falls between 1 and 9.9. I moved my decimal place 1, 2, 3, 4 spaces over. So that means that my exponent is going to be a 4. I know that my exponent is a +4 because I know that positive exponents represent big numbers, and 67,000 is a big number, right? If, however, I started out with a really, really little number, like say 0.0000031, that's a little number. So I know that my final answer is probably going to have a negative exponent. Here's my decimal point. I'm going to move it over to the right this time to land at a number between 0 and 9.9. I'm going to move it over 1, 2, 3, 4, 5 spaces. All right, so my new number is 3.1. I moved it 5 spaces, and it was originally a small number. so my exponent is going to be -5. Right? Again, you can pause the video, you can attempt problems 6, 7, and 8 by yourself, or you can watch me do it, does not matter to me. To express the number 45,000 in scientific notation, I find my little invisible decimal point and I move it over 1, 2, 3, 4 spaces, and I get 4.5 times 10 to the 4th. For problem number 7, I find my decimal place, I move it over 1, 2, 3 spaces, and I get 8.7 times 10 to the -3rd. Problem number 8, I found my invisible decimal point, I move it over 1, 2, 3 spaces, and I end up with 3.2 times 10 to the 3rd. All right. Now, we're going to start talking about math with scientific notation. If we are multiplying two numbers together that are both in scientific notation, we are going to break that problem up into two basic steps. So let me give you an example problem and we'll work through it. Let's say that I am multiplying the number 3.0 times 10 to the 3rd. And I'm multiplying that by the number 2.0 times 10 to the 4th, right? Though that looks like a complex bit of math to do, but we can break it up into two main pieces. There's this piece right here, and I like to call that piece the raw number, right? We're just looking at a plain number. Since we're multiplying, I can just multiply those two numbers together normally. 3 times 2 gives us 6, right? I just did that normally. Now, the second bit of this multiplication is our exponent piece. And our rule states that when we are multiplying two numbers in scientific notation, the exponents are added together. So what that means is I'm going to end up with times 10 to the something. And so I'm going to add that 3 and the 4 together. 3 plus 4 is 7. All right, so my final answer is 6.0 times 10 to the 7th, which seems really, really weird. So let me write everything out in standard form just so you can see the math that we did. If I write 3.0 times 10 to the 3rd in standard form, that's 3,000. I multiplied that by 2.0 times 10 to the 4th, which is this number. Right? So really what I'm doing is I am multiplying 3,000 by 20,000. If I do that, we can use a little math trick. We're going to get a 6, and we're going to just tack on our zeros, right? This has 3 zeros, that has 4. So we're going to end up with 1, 2, 3, 4, 5, 6, 7. These two numbers are equivalent to one another, right? So I could have written it out in standard form, or I can just use that shorthand little trick to do it quickly and without even using a calculator. All right. Second rule, if I am dividing with scientific notation. Let's say that I am dividing 9.0 times 10 to the 5th by the number 3.0 times 10 to the 2nd. All right, so just like before, I have my raw numbers, and I can just divide those normally, right? 9 divided by 3 is 3. And then I have my exponent piece, right? These two. And our rule says that if we're dividing two numbers in scientific notation, we can just subtract those exponents. 5 minus 2 is 3. So I end up with 3.0 times 10 to the 3rd. right? So if you're not sure, if that doesn't make sense to you, let me write it out longhand, just like I did above. 9.0 times 10 to the 5th looks like this, right? 3.0 times 10 to the 2nd looks like this. When I divide numbers like that, you may have learned this in math, but you can just go ahead and cancel out any zeros and then divide the rest normally. So you're going to end up with that number when you divide that out. This number and this number are the same. So it's just a little shortcut. All right, example number 2 is super important because a good portion of you are going to end up doing this wrong unless I tell you about it right now. So let's say, for example, I was doing, let's say, actually, you know what, let's just use mostly the same problem. Let's say I was doing 9.0 times 10 to the 5th, but this time I'm dividing it by 3.0 times 10 to the negative 2nd instead of 10 to the 2nd, right? We're going to break those up. We're going to divide our raw numbers normally. So I'm going to get 3.0. But with my exponent step, it's not 5 minus 2 anymore. It's 5 minus negative 2. And that is 7, right? 5 minus negative 2 is not 3. 5 minus negative 2 is 7, because subtracting a negative is the same thing as adding a positive mathematically. So if you don't believe me, let's write it out longhand and let's look at what we're actually doing. 900,000 is the same thing as 9.0 times 10 to the 5th, just like last time. But this time our denominator, that 3.0 times 10 to the negative 2, is actually this. That's what we're doing, right? So it's obviously not going to be the same as this. If you divide 900,000 by 0.03, you actually get this, right? That is a much bigger number, and if you don't believe me, plug it into your calculator and see. All right? So, once again, you can go ahead and pause the video right now, or you can stick with me as I do this, but I'm just going to talk you through these problems real quick. Problem number 1, we have our raw numbers, which we are going to multiply together normally. When we do that, we get 45.6. We have our exponent bits. Since we're multiplying those two numbers together, we're going to add them. 10 to the 5th, 10 to the 2nd, so we get times 10 to the 7th. That number is an improper scientific notation. 45.6 is not between 1 and 9.9, so actually we're going to need to scooch that decimal over 1, making it 4.56. 45.6 got smaller by 1 move of a decimal place. So to compensate, my exponent is going to need to grow by 1 number. This is our final answer. All right, number 2. We have our raw number bit, 6.8 divided by 9.8, so we can divide those normally. That's going to give us 0.69. We have our exponent bit, 34 and 26, so we're going to do 34 minus 26, and that's going to give us times 10 to the 8th. Again, improper scientific notation, so we're going to need to scooch that decimal place over 1. And that is going to turn it into 6.9. 0.69 got bigger by 1 decimal place scooch, so our exponent is going to have to shrink by 1 number to compensate, and that is going to be our final answer. Finally, we have our last one, 8.90. and 4.5, those are being divided, so we can divide those normally, and that's going to give us 1.978. And then we have our exponent piece, 10 to the 4 minus 10 to the negative 3rd, and that is going to give us times 10 to the 7th. Now, If we're paying attention to sig figs, like we should be, because sig figs are always important, we're actually going to end up rounding this off a little bit. We're going to round it off to 2.0 because this number right here has 2 sig figs in it, and we're going to keep that exponent. If you have any questions about how scientific notation works, please come talk to me.